I am going to be sharing how to model continuous moves going back and forth from a depot. So I am in the NextMove Farm Share demo account right now, and I'm in the routing app where I've subscribed from the NextMove routing app in our marketplace. And so I'm going to go to my run history since I have an example of this in my run history. And let me open up this run, which has a name restrict to singular moves from the depot. So this is the typical way that users will model the distribution problem. And you can see here that the vehicles all have a default start location and a default end location. So this is kind of the most basic way to model a distribution problem where the vehicles start and end at a certain location and it's fixed for every vehicle. And then in the stops array, you're just passing essentially the drop-offs. And the vehicles have a capacity. So in this case, we have one vehicle with a capacity of 200. And so you can see here the vehicle with a capacity of 200 has to pick up drop off all of these stops. So that's why the quantities are negative, because we're essentially starting that vehicle at the beginning of the route with a full capacity and then decrementing that quantity for each stop. And this is a way that we can model the distribution problem. And so if we look at the result of that run, we can see that we have some stops unassigned in red because we only had one vehicle with a capacity of 200 and they had to start at the depot and could not return to the depot once the vehicle was full up with their capacity. And so we can see here that in this case, the vehicle starts at the depot and then goes and drops off at location 7, then 5, then 4, then 2, then 3, then 1. And then the route ends with those stops unassigned. So now if we want to understand how to model continuous moves from the depot, we can look at this input example. And so here, instead of modeling the stops array as only the drop-offs, we include both a pickup stop and a drop-off stop for each particular drop-off location. And in this case, since it's still a depot problem, every pickup has the exact same pickup location, which is the start location of the vehicle. And so we can see here, we're basically just adding these placeholder pickup stops in for the depot, since every drop-off has a pickup, which is the depot. This allows a little more flexibility so that you can allow for multiple trips to and from the depot instead of just one per vehicle. And so the main changes between this file and the previous are what I just described, having that pickup stop. Another change is that now pickup quantity is negative since the pickup decrements the capacity, and the drop-off quantity is positive because the drop-off gives capacity back to the vehicle. And this is what allows us to be able to dynamically fill and empty a vehicle within a single route. Another change is that on each pickup stop, we have this new field called proceeds, which says that the pickup has to precede its corresponding drop-off. So the pickup 1 stop precedes drop-off 1, and pickup 2 stop precedes drop-off 2, and so on. Other than that, everything in this input file is the same. And if we look at the result, we can see that now all of the stops are assigned. We don't have any unassigned stops anymore. And if we hone in on the route, we can see that we have a bunch of pickups, and then we do some drop-offs. And then we go back and do another pickup at the depot, another few pickups, and then we drop off. So this is how you can model a distribution problem with a little more flexibility to allow multiple tours to and from the depot.